So, artificial intelligence, AI. You hear that term thrown around everywhere, right? But what does it really mean? Well, over the next few minutes, we're going to cut through all the noise and make this whole thing super clear. All right, so here's what we're going to cover. First, we'll look at the AI you're probably already using every single day. Then, we'll dig into what AI and its powerhouse, machine learning, actually are. After that, we'll see the three main ways machines learn, how you build a smart model from scratch, and wrap up with some of the real-world challenges and tools of the trade.
Okay, first up, let's talk about where you actually bump into AI. Because, this isn't some far-off sci-fi concept from the movies. It's here, right now. And it's working quietly in the background of your life.
I mean, it's kind of creepy sometimes, right? How does a streaming service just know the perfect show you're in the mood for? Or when a shopping site suggests something you were literally just thinking about? That's not a psychic on the other end, that's AI doing its thing.
Just think about your day. When you use a map app to dodge traffic, that's AI. When you ask your phone for the weather or unlock it just by looking at it, yep, that's AI too. Even something as simple as your email automatically filtering out all that junk mail, that's all powered by AI technology. It's everywhere. So, we've seen it out in the wild. But what's the actual, big idea behind artificial intelligence? Let's zoom out and get a solid definition. At its heart, AI is really this massive, incredible goal: to build computers that can simulate how a human brain works. We're talking about building systems that can reason through problems, learn from things that happen, understand what they see and hear, and even make decisions. Basically, all the stuff we thought was unique to us humans. Now, this is super important to get right off the bat. Every single piece of AI that exists today is what we call narrow AI. Think of it like a specialist. It's an absolute genius at doing one specific thing, like understanding your voice commands or becoming the world's best chess player. But it can't do anything outside of that one single job. The next step up, the thing that researchers are dreaming about, is general AI. Now, this is the AI you see in the movies, a machine that has the same kind of flexible, learn-anything intelligence that we do. It could write a poem, then fix a car, then figure out a complex scientific problem. It's the ultimate goal, but let's be super clear. We are not there yet, not even close. And then there's super AI. This is pure science fiction territory for now. It's the idea of an AI that would eventually become smarter than the smartest human being in every single way. Creativity, social skills, scientific genius, you name it. It's a mind-bending concept, and for some people, a little bit terrifying.
So, how do we get a machine to be intelligent, even in that narrow, specialized way? Well, the answer, the engine that drives pretty much all modern AI, is a fascinating field called machine learning.
Okay, this is the real game changer. In old-school programming, a person had to write out every single step, every rule for the computer to follow. With machine learning, you flip that completely. You don't write the rules. Instead, you just show the machine a ton of examples, a whole lot of data, and you let it figure out the patterns and rules for itself. It actually learns and gets better all on its own.
So this whole learning thing, it doesn't just happen one way. There are actually three main flavors, and the easiest way to remember them is to think of a teacher, a detective, and a personal trainer.
First up, you've got supervised learning. And honestly, the best way to think about this is like you're a teacher with flashcards. Let's say you want to teach a computer to spot pictures of cats. You'd show it thousands of pictures, and each one would have a label: cat or not a cat. The machine sees the picture, the question, and the label, the answer, over and over again, until it learns what a cat looks like. Next, we have unsupervised learning. Now, this is where it gets really interesting. You give the machine a giant pile of data, but, and this is the key, with zero labels. You don't give it any answers. Its job is to be a detective, to sort through all the clues and find hidden patterns and connections all by itself. This is how companies can discover different groups of customers who behave in similar ways, without even knowing what they were looking for. And the third type is reinforcement learning. This one is all about trial and error. Seriously, it's almost exactly like training a puppy. The AI, or agent, tries things out in its environment. When it does something good, you give it a reward, like a point. When it does something bad, you give it a penalty. After millions of tries, it learns the best possible strategy to get the most rewards. This is exactly how AI has mastered incredibly complex games like chess and Go. Okay, so we get how machines learn, but how do you actually, build one of these smart models?
It might sound like magic, but it's really more like following a recipe, a very logical, step-by-step recipe.
It all kicks off with data. You have to gather your ingredients first. Then comes a really crucial step. You have to clean and prepare that data. Get rid of errors, fix missing pieces. After that, you pick your algorithm, your recipe. Then comes the fun part, training, where you let the model cook and learn from the data. But you're not done. You have to evaluate it, test it, and see how well it actually performs. And only then, once you're happy with it, you can finally deploy it out into the real world, where you have to keep an eye on it to make sure it's still doing its job right.
Now, of course, making that recipe work in the real world, well, it's not always a walk in the park. Let's touch on a couple of the classic challenges that everyone in this field deals with and some of the tools they use to solve them.
One of the very first things you have to figure out is, what kind of question are you even trying to answer? Are you trying to predict a number on a sliding scale, like the price of a house or the temperature tomorrow? If so, that's a regression problem. Or are you trying to put something into a bucket, a category, like, is this email spam or not spam? Is this picture a cat, a dog, or a bird? That's classification. Getting that right is step one.
All right, now this next one is a classic. It's the Goldilocks problem of machine learning. On one hand, you have overfitting. This is when your model basically memorizes the training data, including all the weird random noise. It gets an A+ on the practice test, but then completely bombs the final exam when it sees new data. On the other hand, you have underfitting, where the model is just too simple and doesn't learn much at all. The goal is always to find that perfect balance, that just right model in the middle.
So to handle all this stuff, to make life easier, developers don't usually start from scratch. They turn to these amazing cloud platforms. Services like these give them all the tools they need to build, train, and deploy their models without having to reinvent the wheel every time. They have specialized tools for just about anything, analyzing images, understanding human language, or even building chatbots. It makes AI so much more accessible.
Okay, let's do a super quick recap of those big ideas. Remember, regression is for predicting numbers, classification is for picking categories. You always want to avoid overfitting, where your model is too complicated, and underfitting, where it's too simple. And these powerful cloud platforms are what professionals use to manage this whole shebang from start to finish.
So we've gone on quite a journey here, from the AI that's already in your phone to the complex recipe for building it. It's pretty clear, this technology is incredibly powerful, and it's only going to get more powerful. Which leaves us with a really, really big question to chew on. As we create machines that can learn, what are the most important things we should teach them first?